Alright class, we're going to continue talking about acid bases, but what I wanted to do, I wanted to kind of summarize everything we've talked about, okay? So let's do that before we do practice problem. So what we talked about, we said back in Chem 1A, we told you that if a compound starts with H, that's an acid. If a compound ends with OH, that's a base. But that is so Chem 1A. We're a lot fancier now. So we're going to use a different definition of what's an acid and what's a base. Now, we said that acid loses hydrogen, base gets a hydrogen. Acid loses a hydrogen, base gets a hydrogen. Also, I want you to remember that to be a base, to be able to gain H+, to be able to gain a hydrogen, you need to have extra electron so you can afford it, right? So this is what it means to be a base. The base needs to have some sort of lone pair or extra electron to be able to go and grab the hydrogen. And don't forget, I said sometimes we write H+, but the correct way of writing it is hydronium, because every time H+ is around, water will grab this H+ so quickly and form hydronium. So the hydronium is a better way of writing it, but sometimes I do it too. I write H+, it's a little bit easier, simpler to write, but again, they're the same thing. But you know, because you're fancy now, that if H+ is walking around, water will grab that H+ so quickly and form hydronium. Then we said strong acid and bases are the ones that will completely and 100% dissociate. They're going to break up completely in water. And weakest acid and bases, they were going to partially dissociate in water. So every time you have a weak acid or base, you are going to have an equilibrium. So every time you have a weak acid or base, you are going to have an equilibrium. And every time you have an equilibrium, you have an equilibrium constant. Ka for acid, it's kind of cute. Kb for base. Then we said, because all of these things are happening in water, because water is our solvent, there is a relationship that needs to be considered. And we talked about Kw. That's the equilibrium constant for water, which is hydronium concentration times the OH minus concentration, and the Kw at 25 degrees Celsius, that is a constant, and that constant is 1.00 times 10 to the minus 14. Okay, beautiful. And then we said, based on this, what that means is if you have pure water, the hydronium concentration is going to equal the OH minus concentration. And if that's the case, that means our pH is neutral, right? And we talked about the pH. That means pH is going to equal 7. That means we have a neutral solution. Now, if the hydronium, it has a larger concentration on hydroxide, that means we have an acidic solution, right? And if you have an acidic solution, that means the pH is going to be less than 7. And we said is the hydronium concentration is less than hydroxide concentration, that means you have a basic solution, or you're going to have a pH that is greater than 7. Okay, now you talked about, so again, don't forget this is Kw, hydronium times OH minus concentration, and you know this one. Then we said people don't really care about hydronium concentration and hydroxide concentration. We care about it, but the normal population, you don't want to talk about hydronium concentration in your water or the hydroxide concentration. So what they did, they take concentration and they turn it into pH, which is much easier to use. And then how do we figure out the pH? Is minus log of hydronium or minus log of H+. These two are the same thing. You know, this is more correct, but sometimes we write H+. Now, that would be from 0 to 14. 0 to 7 is acidic, 7 to 14 is basic, and if you are 7, you are neutral. Again, if you're neutral, you have a pH of 7, that means your hydronium and your hydroxide concentration is equal. But pH is easier to communicate than using concentration. Then we said we have another scale that is pOH, which is minus log of OH minus, and don't forget the relationship. pH plus pOH equals 14. So far, so good? Okay, so it kind of summarizes everything we've talked about. Now, let's do our first practice problem. Okay, aspirin has a hydronium concentration of 1.7 times 10 to the minus 3 what is the pH? Okay, so I want to go back here. I know this is the equation for pH. This is the formula for pH. So pH is minus log of hydronium concentration. You guys agree? Okay. Well, hydronium concentration is given to me, so this is going to be easy to figure out. So pH is going to equal minus log of 1.7 times 10 to the minus 3. Make sure you take your calculator out and do this for me. Okay. Now, my final answer with the correct number of significant figures, yeah, don't forget sig fig, is 2.77. Okay. Now, I can see your confused faces right now. What did she just do? What was she thinking? This is 2 sig fig. This is 2 sig fig. Now, 2.77 is in that 3 sig fig. So how is this correct number of significant figure? You agree that, I agree with you, you're right, that I am limited to 2 sig fig. But check this out. This is log. It's a little bit different. This is 2 sig fig, 1.7. This 7, this part comes up. What did I just do? This, let me make it a little bit. This part comes from 1.7. Now, the 2 is from 10 to the minus 3. So this is why when you do log of a number, you have to count after the decimal place. That's what's going to count for number of significant figure. Because log of 1.7 times 10 to the minus 3, the minus 3 gives you the 2. The 1.7 gives you 77. This is 2 sig fig. This will consider 2 sig fig. So far, so good. So 2.77 is the correct number of significant figure. I know it's a little bit confusing. We'll do more of it to make sure that you get this down. So far, so good. Okay. Ready for next practice problem? Let's do it. Pause me, do this, and I'm going to go over it. Window cleaner has a pH of what at 25 degrees Celsius if the hydroxide concentration is 3.7 times 10 to the minus 3. There are 2 ways to do this, okay? There are 2 ways to solve this problem. I want to show you the way that I like, and I'll show you the other way too, in case if you did the other way. If you like that way, I'm not going to judge. You can do it. Every time you have a hydroxide concentration, you cannot figure out pH. But what you could figure out is pOH, because pOH is minus log of OH minus concentration. So every time I have a hydroxide concentration, what I could figure out is pOH, right? What I could figure out is pOH. I have the hydroxide, so why not? Let's figure out what I could figure out, which is pOH. So minus log of 3.7 times 10 to the minus 3 molar, okay? If I do that, you do it with me, I'm going to get 11.5, no, that's not what I'm going to get. I'm going to get 2.43 is going to be my pOH, okay? That's what I got. Because I good so far. And I need 2 sig fig. 4.2 after the decimal is what matters. 2 sig fig, because the 2 goes for that. Okay. Now, this is pOH. The question does not ask you for pOH. The question asks you for pH. But I had OH minus, so it made sense to figure out pOH. Now, that's not a problem, because we know the relationship between pH and pOH. If you add them together, you're supposed to get 14. So all I have to do, subtract the pOH from 14, and what I end up getting is 11.57, and that was a weird 5. And this would be my pH. This is going to be my pH. You guys follow that? Okay. I like this way a lot more. I like doing it this way more. So you have the OH, you figure out the pOH, you can subtract it from 14, and then you figure out the pH. Now, here's another way to do it. If you did it this way, no judgment. For pH, you need hydronium concentration, right? and you don't have hydronium concentration, but you have hydroxide concentration. Well, there is a way to figure out the hydronium concentration, and that is Kw, because Kw is hydronium concentration times hydroxide concentration. And I have the Kw, that's a constant, right? I have the hydroxide, and I can figure out the H3O plus. Exactly. So Kw is 1.00 times 10 to the minus 14 equal, I do not have the hydronium, but the OH concentration is 3.7 times 10 to the minus 3 molar. So far so good. Okay. Now, if I solve for X, what I end up getting for X is 2.7 times 10 to the minus 12 molar. And what is X? What X is going to be my hydronium concentration. Okay, this is great. Now what I have hydronium concentration. Now I'm back in business because I know that the pH, to figure out the pH, is minus log of hydronium concentration. And now I have the hydronium concentration. It would be minus log of 2.7 times 10 to the minus 14 molar. You guys are good so far? Now if you do that, what you end up getting the same answer. 11.57 would be the pH. You're not going to get an answer. So far so good? Okay. So to me, the easier way for me is I see OH, I can figure out pOH. And that's okay. Then I can subtract from 14 to figure out the pH. Or if I have the hydroxide concentration, I know how to figure out the hydronium concentration using Kw. Once I have the hydronium concentration, then I can plug it into the pH equation. So far so good? Okay, ready for next problem? Let's do it. What is the pH of 0.0001 molar lithium hydroxide? Okay, I didn't give you the hydronium concentration and I didn't give you the hydroxide concentration. So what's going on here? Well, I give you lithium hydroxide, right? Now, one thing to remember is that lithium hydroxide is a base, but it's a strong base, right? Because lithium is in group 1A. So if I have lithium hydroxide in water, I would have 100% dissociation. It would break up into lithium and hydroxide. Do you guys agree? So it's a strong base, so it will have 100% dissociation in water. Well, that's great. So now I know how much hydroxide I have. Now remember this. So I have 0.0001 molar of lithium hydroxide. If you are a strong base and you have 100% dissociation, that means that every single lithium hydroxide is going to break up into ions. You agree? If every single lithium hydroxide is going to break up into ions, what's going to be the concentration of hydroxide at the end? The same. Because if I have 100 lithium hydroxide, I end up with 100 hydroxide. Because every single lithium hydroxide is going to break up. So far, so good? Okay. So now I have the hydroxide concentration. Well, I have the hydroxide concentration. What did we talk about? I can figure out the pOH, right? Every time I have hydroxide concentration, I can figure out the pOH. So it's going to be minus log of 0.0001 molar. If I do that, what my pOH is going to be is going to be 4. Okay. Now I have pOH, but what I want is pH. But that's okay because I know pH plus pOH is equal 14. So all I have to do, just 14 minus 4 is going to give me 10. And 10 is going to be the pH. The pH is basic. Is that what you expected? Yeah, you have a strong base. That's what you expected. That's pretty cool, right? Okay, there's one more thing I forgot to talk about because it's really cool. Can I talk about it? I'm going to go back really quickly. This is a window cleaner, and if you remember, I said most of the cleaning supplies have a pH that are basic. Hey, look at that. I wasn't wrong. Now, the first problem, I gave you an aspirin, and the pH of aspirin ended up being 2.77. Aspirin is pretty acidic, and this is why a lot of people, when they take aspirin, they get upset stomach, because aspirin is on an acidic side, 2.77. That's pretty acidic pH. So next time you take an aspirin, I want you to think about that. Say, oh, I know the pH of aspirin is pretty acidic. So far, so good? Okay. Are you ready for next problem? Let's do it. Here's the next problem. Please pause me. Do this problem, and then we are going to go over it together. Okay, what is the pH of 0.020 molar sulfuric acid? Now, I know that sulfuric acid is a strong acid. Okay, so I know that sulfuric acid is a strong acid. So far, so good. Okay, so sulfuric acid is a strong acid. And to have a strong acid, we talked about it, is going to have 100% dissociation in water. So it's going to end up with 2H plus SO4 minus 2, right? Strong acid is going to be completely dissociated in water. So far, so good. Okay. Now, I had 0.020 molar sulfuric acid. If I have a strong acid, which means it has 100% dissociation, that means every single sulfuric acid is going to break up. How many H plus do I end up with? I want you to think about this. Now, before you answer that, I'm actually going to draw a little cartoon diagram to see if you, before you answer this. Let's say, okay, bear with me. I want to do a little cartoonish here. It's fun to teach this way. Here, I have two molecules of sulfuric acid, right? H2SO4, H2SO4, right? I have 1, 2. I have 2 sulfuric acid. When these 2 sulfuric acid, when they break up in water, because it's strong acid, everything is going to break up. I end up with 2 SO4 minus 2. And how many H pluses do I end up with? I end up with 1, 2, 3, 4 H pluses, don't I? Okay? So when I have 2 molecules of sulfuric acid, when everything breaks up, I end up with 2 sulfate and 1, 2, 3, 4 H plus, right? Or we know it's hydronium to be more correct. Now, why is that? Because there's a mole ratio. For 1 sulfuric acid, you have 2 H pluses. So in here, if every single sulfuric acid breaks up, and I have 0.020 molar sulfuric acid, how much H plus do I end up with? Double of that, 0.040 molar. If you're having a hard time, think about this. I had 2 molecules here, right? I had 2 molecules here. I ended up with 4 H plus. I had 2 H2SO4. I ended up with 4 H plus because it's a 1-to-2 ratio. For 1 H2SO4 that breaks up, I end up having 2 H plus. So the concentration of H plus is 0.040. That makes sense? Okay. Hopefully you guys follow that. Okay. So now I have the H plus concentration. For pH, that's all I need because pH is minus log of H plus concentration. And this is why I'm getting to H plus. This is why I need OH minus because that's how I can figure out pH or POH. Having H plus, having OH minus. So minus log of 0.040 molar, okay? So what I end up getting is 1.40 is going to be my pH. You guys are following me so far? Okay. Beautiful. Really nice job. So remember, I need you to remember this. What you're looking for every time, I'm going to put remember. So you will remember this. What you're looking for every time you want pH, you want pOH, what are you looking for? You are looking for hydronium concentration, right? Your H plus concentration. You're looking for OH minus concentration. So every time they ask you for pH, they ask you for pOH, look for hydronium concentration, look for H plus, look for OH minus. This is what you have. So whatever they give you, you gotta look for these guys, right? Because that's what you need. That's what you need to figure out the pH or pOH. You need H plus concentration or hydroxide concentration. That's what you need to look for those things. Yeah? Okay. Ready to do the next problem? Let's get a little harder. It's good. A solution is 0.050 molar in HClO. What is the pH? Well, everything I've given you so far, it has been strong acid and a strong base. Now what am I giving you? I'm giving you weak acid. Tricky. So everything I've given you has been pretty easy. It's been a strong acid or strong base, which makes it easier because it will fully and 100% dissociate. So it will be easy to figure out the pH and pOH, right? Now I'm giving you weak acid. How are we going to figure this out? Okay, let's do this together. Remember, every time you have a weak acid, what do you have? You have an equilibrium. So every time you have a weak acid, you have an equilibrium. Write down the equilibrium and think about equilibrium chapter that we did. Every time you had an equilibrium, how would you figure things out? You would figure things out using an ice table. Yeah, the ice table is back. You guys remember that? Initial change and equilibrium. Okay. So again, I have a weak acid. If you have a weak acid, it's not a strong acid. Not everything is going to break up. That means you have an equilibrium. If you have an equilibrium, we got to set up the ice table. Okay? Now, initially, what do I have? I have 0.050 molar HClO. I have none of that, none of that. What is the change? This one has to go away and I have to form product. So far, so good. Equilibrium is 0.050 minus X is X and is X. Nothing you have not seen before. Yes? Yes. Now, equilibrium constant is Ka, is product over reactant. It would be the H plus times ClO minus over HClO, right? Product over reactant. Again, nothing you haven't seen before. Now, these are my equilibrium values. So, it would be X squared over 0.050 minus X. Where do I get the X squared? X times X, right? My product over reactant. My product over reactant. X squared over 0.050 minus X equals Ka. What is my Ka value? I've given it to you. 2.9 times 10 to the minus 8. Nothing, not bad, right? Not bad. Now, do you agree that the Ka is so much smaller than 1, right? This is a small value for Ka. Because this Ka is such a tiny value, I'm going to assume this is 0 to make my math a lot easier, okay? If I assume that's 0, making my math easier, it would be X squared over 0.050 equal 2.9 times 10 to the minus 8. Now it's easier to solve for X. When you solve for X, what you end up getting is, do it on your own, then look at my answer. It's 3.8 times 10 to the minus 5 molar. Now, what does X represent? Remember we talked about, remember this. Remember what we said, pH, pOH. You're looking for H+, you're looking for hydronium, you're looking for hydroxide. What does X represent here? Well, X represents H+, and that's what I need. This is H plus, and that's what I need to figure out the pH. pH is going to equal minus log of H plus. And guess what? I have the H plus now. Minus log of 3.8 times 10 to the minus 5. Okay, so if I do that, then what the pH is going to equal? pH is going to equal 4.42. And why is it 4.42? Because I'm looking for 2 sig fig, right? This is 2 sig fig. And we talked about it, when you do log, you have to consider after the decimal place. This is 2 sig fig. You guys follow that? Okay. Hopefully you follow that. Again, every time I give you a strong acid or a strong base is easy, right? But if I give you weak acid or base, equilibrium, no question about it, and equilibrium constant. And you set up the ice table. Okay. Now, let's give you a take-home problem, yeah? Or in this case, stay-home problem. Stay home and do this. What is the pH of a 0.35 molar ammonia solution? The Kb equals 1.76 times 10 to the minus 5. Please do this. This is a good problem. I need you to do this for me, okay? Because every time you have weak acid or base, you have to think about equilibrium. All right, we did a lot. Beautiful job. Do the take-home problem, and I will talk to you guys next time.